So, hello everyone. Okay, so we'll try to solve another graph problem today. Let me go directly to that problem. So we are trying to solve number of islands. It's classified as a medium problem, and it has been asked in Amazon, Bloomberg, and Google. So first of all, we'll try to again go with the similar approach where we try to understand the problem thoroughly, no matter how much time it takes. And then we'll go about solving this problem and writing the code for it. So first is understand the problem. Second, try to come up with a solution. And third one is write the actual code for this. Okay. So the problem says given an M cross N 2D binary grid, which represents a map of ones and zeros, meaning land and zeros meaning water, return the number of islands. An island is surrounded by water and it's formed by connecting adjacent lands horizontally or vertically. So what it means is four directionally adjacent. Okay, cells. So they will be classified as connected. You may assume all four edges of the grid are surrounded by water. So in turn, like basically, even if there are all ones in the grid, even then that is one island. Okay, so because it's already surrounded by water from all sides. Okay, so what we'll try to do is we'll again go to the whiteboard first, and then we'll try to visualize the problem. Okay, let me do that. It's taking a lot of time, but let's see. Uh, we'll create a new whiteboard. Okay. Let me change the settings. Format background. Okay. I like it this way, and let's work with this. Okay. So what we have been given is we have been given a grid. Uh, Grid says okay one. Okay. Let me first draw the grid. One, 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 zero. Last row is all zeros. So in this case, why the answer is one is you can see. Let me use some other color if possible. This is one island, okay? Because on all four sides it is surrounded by water. Okay, so it's kind of a flood fill problem where if we come to this element, okay, we just need to look outwards in the four directions possible and keep connecting these ones, okay? So it's a variation on the flood fill problem that we can see, but in flood fill we had to change the values of all these ones which were connected to, let's say, this particular one. Okay, we were changing the values to a new color in that case. In this case what we'll do is We have to keep track of what element we have visited. Okay, so either we can change it the value, because since the grid will only be containing ones and zeros. So one way is to approach this problem, this kind of problem usually is maintain a visited array, okay, which will look at each position. It will store whether that particular position has been visited or not while doing the recursive calls, okay. That is one approach. Another approach in this kind of situations, which I usually like to do is, I like to change the values of the cells that I have already visited. So for example, if I have already visited this particular one, I'll change it to, let's say, -1 or -2 or something like that. Okay. It will help me save on memory, because in if I have a Boolean grid for visited, it will add a space complexity. Okay. So, what we'll do is, we'll once we have visited an element, change its value to, let's say, -1 or -2, to mark it as visited. So it's again, the approach is DFS, depth first search. So what we are doing is, we are coming to, let's say, we'll start, in this case, we'll loop all of the elements, okay? So we'll start from 0, comma 0, perform. So whatever we did in the previous video, which is flood fill, we did nothing but DFS, where we were looking at the adjacent members which were matching the same color. Okay, so in this case, it's also the same kind of problem, where we are looking for ones that are directly connected to a certain cell which contains one. So if 0, 0 contains one, then we perform DFS to find all cells which have one and which are 4 directionally adjacent to 0, 0 in this case. Okay. Uh, if so, it is part of an island containing 0, comma 0. Okay. So in this case, if we look outwards, we will look at this element, we will look at this element. If these are ones, then we can say, okay, 0, comma 0, 1, comma 0, and 0, comma 1. These are all belonging to same island. Similarly, we'll do recursively for all of these elements. For this one, we'll visit its neighbors and we'll again compare. Okay. The one advantage that we have is, we know for sure that this grid will only contain value 0 and 1. It will only contain either the land or water. Okay. So we don't, it's kind of like similar to flood fill, where here we know that the old color in this case will be 1 only. Okay. And the new color, we can mark it as a visited. Okay. We can use it as a visited flag basically. Okay. If so, it is part of an island. Then do this recursively. Okay. Again, in this case, what we can see is, okay, these four belong to one island, but since this is diagonally opposite, not the four directionally adjacent, so this one will not be part of this island, okay? Similarly, this one will be isolated from this island. So there will be three islands, which as you can see, it's shown. Now what I want to do is, I want to do one iteration to show how this will look like, okay? Okay. In our code, what we'll write is, we'll first visit 0, comma 0. Check if it is land. If it is water, simply skip it because it won't be helping us in counting the islands, right? Because all of the island will have land, right? Land value. So I'm I'm taking this example itself where in our case 0, comma 0 is a land, okay? So what we'll do is we'll visit it, we'll perform a DFS on its neighbors. But when we are doing that, we'll visit it and we'll mark it as a flag, okay? So as I mentioned, right, to mark the visited nodes, uh, visited nodes, convert them from 1 to -2, let's say, okay? So we will visit 0, comma 0 and we'll mark it as visited, okay? But we also will call recursively, we'll perform the DFS on its neighbor, okay? So initially when we have changed the value, it will look something like this. It won't be changing 0, 0, 0. It will look something like this, okay? Now, when we perform the DFS on this, we'll be visiting this one, we'll be visiting this one. And to the top and the left, there are no elements, so the function will directly return it, okay? As it is. So we'll visit these two neighbors, and during this time, we are still at trying to find the island, okay? This is one island only. So every time we find an island, increment count. Okay. So as soon as we found first land, we knew that this is for sure one island. So we will increment the count by one. Count becomes one in this case. So let's come back to this where we were visiting the neighbors of this particular cell. Okay. So we'll visit it, we'll mark it as -2, and yeah, we will do, this will remain 1, 1, 1, 0, 0, 0, 0, 0. Sorry, it's getting confusing to look at. Let me just clear it out. Okay. Okay, this will look like something like this in the next iteration of the DFS, basically next stage of DFS. 1 1 1 0 0 0 0 1 1 0 0 1 0 0 0 0. It will look something like this. Again, we'll perform DFS for these two. Okay, so its neighbor will be these two, and its neighbor will be these two. So as you can see, I won't do the whole iteration, but you can see it will keep on propagating this -2 value, keep on visiting the adjacent elements as long as it is four directionally, which is this one, this one, this one, as long as four directionally one is available. So at end of first DFS, it will be -2, -2, -2, -2, 0, -2, 0, 0, -2, -2, -2, -2, 0, 0, 0, 0, 0. Got it? So what -2 does is, so we initially started from 0, comma 0. If you remember, we started from 0, comma 0. And we kept on doing DFS until we were able to find all the ones, and we marked is them all by -2. Okay, so in initial first condition we will if it is water we will skip it, or if it has been visited we will skip it. Okay, so similarly what we'll do is in this case there are no more ones left. Count will remain 1, and so the answer will be one island in this case. Okay, hopefully it is clear. If we take, I'll take the another example as well so that it's the most, there are no more doubts left. Okay, let me just draw that grid out. What it says is 4 times 1, 1, 1, 1. Okay, as you can see, this is one island, this is one island, there are three islands. You can already see this. So again, how the our solution will work is always start with 0, 0. Again, here we are lucky, it's a land. So perform DFS and mark all ones connected as visited. So it will look like -2, -2, -2, -2, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1. And we'll This is the island counter. Let's call it island counter equal to 1 here. Next stage. After visiting 0, 0, it will not visit this one because it's minus 2. It will not visit zeros because, as we discussed previously, we will only do DFS for values equal to 1. So it will skip this also, this also, this also, this also, until it comes to this one. Okay. Again, it will try to perform DFS on this. Now it will look like minus 2, minus 2, 0, 0, 0, minus 2, minus 2, 0, 0, 0. This is minus 2, 0, 0, 0, 0, 0, 0, 0, 1, 1. And this counter is becoming 2. And why only one of the cell changed to minus 2? Because there are no ones adjacent to this one. Okay. Similarly, it will happen for this one. So, so similarly, island counter will become 3. This will be the end grid will look like this. Okay. Answer is 3. Okay. As we can see, it is 3. And just to make sure that what all values, so it will only take 0 and 1s, as you can see. Mn value can be till 300. So now let's try to code the solution out. Okay. How the code will look like, we will again start from this canvas only. Let me move this on side. Or should we keep it for reference? No, let's move it aside. It's much clearer. Okay. Let's look at the function public int num islands. So we are given a character grid. So just be careful, we are not given an integer grid. Okay. Now write the code for this one. Okay. First of all, let's initialize the m and n variables. M is the number of rows, which is in Java we take it like this, grid.length. This will come handy actually. This is how we take out number of columns. Now this is present. So what we can do is, as I mentioned, right, I was modifying the value so as to save space, okay, from the space complexity point of view. You can also have a Boolean visited array, okay. This will also work. Should we try that or should we directly go to? Let's try this, okay, just so I can show you. Boolean visited equal to new Boolean m n. So we have initialized the Boolean array. Okay. Now what we need to do is, if we go back to our reference, what was it? Yeah. We go one by one across the grid. We start from 0, comma 0. So we need to write a for loop here to start from 0, comma 0. So we will have for I equal to 0, I less than m, I plus plus, and another for the rows. Okay. What we will do is, if visited I comma j is true, or grid I comma j is equal to 0, basically we should have the reverse condition actually, because we will do only processing. Yeah, so we will negate it. Okay. If visited is false, what this means is it will go into the if condition only when the visited ij is false. Okay. Then only it will execute this if, whatever is inside that if. Because we only want to do processing for the non-visited element. If it is visited, we don't need to do any processing for this, because we trust our program that it has already performed the DFS on it. It has already taken out the useful information of number of islands while calculating that. Okay. So this is the first condition. Okay. Another thing is, it should not be zero. Okay. Whatever cell that we are visiting, it should not be zero because it's water. It won't be helpful in counting the number of islands. Okay. And yeah, we can initialize a variable for num islands as zero initially. Now, again, like previous problem, we will write a method. We'll write the whatever processing will be done in this method or function. We'll write these details. Okay. First of all, just assume that we have a fill. This will perform DFS. Okay, for us. So we will provide it grade. We will provide the column and row and column value, as well as visited array. It will make sure to visit all of the neighbors or of that particular island which contains ij. Will visit all island ones which are part of island made consisting of. Okay. It will visit all ones which are part of island formed by I comma j. Okay. And increment the count because this is a new island that we have found. Okay, every time. And after that, return num islands variable, basically the counter. Let me change this count variable also because it's called num islands in our case. So we will write accordingly. Okay. Now we need to implement this function which is performing the DFS. Fill, we are providing grid. So I'm just writing a pseudocode. It's not syntactically correct. We will manage that, no problem when we write the code. Again, the condition will be if I is less than 0 or j is less than 0 or I is greater than or equal to grid dot length or j is greater than or equal to grid 0 dot length return. Okay, and again this will return void because we are just using it to perform DFS. We are not returning anything, right? Because it's passed by reference. Passed by reference. We modify this directly this grid. We are not creating a new grid altogether. In that case, we will be returning something new, okay? And that's why the return type is void here, okay? Okay, now we have the exit condition. Now what if the element that it is reaching while performing DFS, what if it is 0 or if it has been visited? Again, we have to have the exit condition, okay? If grid ij is equal to 0 or visited ij is equal to true, return. Okay. Once that is done, this is the actual processing step where we visit this I comma j, mark it as true, and call this fill for directionally on all its neighbors. Okay. We will do I minus 1 comma j visited. And similarly, okay, this will be called 4 times with different values. So j, I comma j plus 1, I comma j minus 1. So we have written the code. Now let's try to write it out. Okay, we'll code it out on the editor as well. I will write the same thing. First of all, there are two variations. So this will have space complexity implication because of this visited. Okay. Let's write it out. Let's see, okay, whether the first iteration of our code is working or not. So I'll just put this aside and I'll just start writing the code directly. Let's go back. Okay, first of all, we initialize the m and n variables, right? Then we want to make sure that we visit all elements within this grid. Okay. Before this, we also need to initialize the Boolean visited. Okay. See, I'm doing the same thing. I'm not writing anything different. And this is the final result. Okay. This will be storing. If grid ij is e is not equal to 0, because only then we will perform DFS. Okay. Otherwise, we won't be caring about zeros at all. Just forget about it. It won't be helpful in calculating the number of island because it's not land, it's water. Okay. Or if it has already been visited, then if it has not been visited, okay, that's the condition. Then only it should go in the if condition. Fill, fill is not the correct keyword actually. I think I should call it DFS for better understanding. Let's call it DFS, okay? Grid I j visited and increment the counter, and ultimately we return num islands. Okay, now we write the function for performing DFS. Okay, it's a character grid, never forget it. Write the boundary conditions. If r is less than 0 or c is less than 0, or r is greater than grid dot length, or c is greater than or equal to, it should be greater than or equal to, you can see that. Okay, return. Okay, this is the exit condition. Next exit condition was when not to perform DFS. Okay, because it might happen that, for example, it while performing DFS, it comes down to this one. Okay, it will visit its neighbor 0, then it shouldn't perform DFS, it should stop right here. So that's this condition that we are writing. Okay, if grid ij is equal to 0, or if it has been visited, I I should use RC actually, not IJ. Sorry for that. Okay, now we do actual processing. Visited RC should be marked as true, and perform DFS on four directionally adjacent elements of this. Okay, again, I'll just copy this. Okay, shall we try it? Looks good to me, but obviously, when we run it, actually, that's when the issues come up. Yeah, it should be an AND condition actually. Here also, I should correct it actually. Let me do that. Uh, mm, It should be and here. Sorry, I've just kept it on side. Let me do this properly. Mm, okay, that's all. The change that we had to do.
So it should be and then we're thrilled to have.
Sorry, this lecture was playing actually. Um, okay, now it says accepted for both of these cases. Let's try to run it, but you will see the space, it's not great actually, and time-wise also, it's taking some time actually. 4 milliseconds, beat 67%. Okay. So one of the optimization that you can do on this approach is you can instead of keeping this whole visited array because why use another grid? Okay, this is extra space that we're using. Once we have visited a certain element, for example, if I have visited this one, I won't be visiting it again at any point of either DFS or while this iterating through each and every element. Once I have seen this element, I won't be doing anything with it. Okay, so I can modify this element. I can afford to modify this element. That's what a variation that we can do is we can get rid of this. Okay, and we will mark our visited nodes by a certain number, let's say -2, because it's an character grid. So we can do that actually. We can use any other character also. It's not just you need to do -2 because I did it, but you can do anything. So in this case, we will have to change this to grid and we will modify it to -2. Okay. Similarly, if it is -2, then we will return because it's visited. Okay. If the grid value is -2. Similarly, we'll get rid of this. Okay. We will get rid of this. Not needed. Not needed at all. Got it. And here we will need to just specify the condition that it should not go into the if. It is RC should not be equal to 2. Sorry, it should be IJ. Got it. What it is saying looks okay to me. Um, to be safe, let's use 2. Okay. I don't know how it will save with -2. Let's use 2. Okay, just to be safe. Mm, -2 should also work, but let's see. Okay. You've got rid of all the. Okay. Let's try. Yeah, it's working. See, the result is 1 in this case. It should be 3 here. Yeah. Let's try to submit it. See, now the time complexity has improved as well as the space complexity has improved. So space complexity in this case, we are not using any variable which varies with the size of the grid. So it will be of 1. Okay. And in the worst case scenario, again, it's kind of similar to flood fill, where we may end up with all of these ones. Okay. We may end up visiting all of these elements in the worst case. Either it will be all ones or all zeros. At max, we'll visit all these elements. So it will be O of Mn. Okay. So if I write it down, time complexity will be O of Mn space complexity should be O of 1. That's what my understanding is. It's constant actually. So yeah, hopefully that helps. Again, I'll share the article as well as the code for this problem with you guys. Hopefully this was also helpful. I did it with -2, but actually in code I have done it with +2. Actually, you should be able to use any character and do the same thing. Okay, just to show you, can I use dollars? I should be able to do dollars as well. Okay, it should work actually. Let's see. Yeah, see, any character should work. That you can mark it, use it to mark whether a certain cell has been visited or not. So that's all for this video. Hopefully you guys found it helpful. Uh, we'll meet with the next problem. Okay. Thank you.